So we've talked about individual lenses, and it's time to talk about lenses in combination. And it's a very natural question, and this is also the way that you figure out how telescopes and microscopes work, is what if I had not one but two lenses? In fact, that's a lens in combination if you think about the lens in the eye. So we'll just do this and see what happens. So let's say that I have a converging and a diverging lens, and they're separated by a distance d. And the overall idea is that it's actually a little bit easier for something like this. We're kind of cheating by using a converging lens. But let me just put an object here, and we'll do our ray tracing business and see what happens. So I've got an object, and it's located at an object distance, so d naught. This we'll call lens 1. And just so we're super clear, I'll put a 1 on that. And this is lens 2. And this has a focus, and the other focus that we might care about in our ray tracing. So we've got rays, we've got in parallel, out through focus, if I could draw, out through focus-ish, in through focus, out parallel, and then we've got our straight through. So at this point, probably, not super mechanical, but at least you should feel comfortable with that. And we have an image. So I'm going to label this with DI. And I'm actually going to label it with DI1, because this is the image from the first lens. Okay, this is the new part. What do we do with this second object? Well, sorry, gave it away. What do I do with the second lens? I basically treat the image of the first one as the object of the second one. And you can see that after we've traced the rays. So the rays, in the case of a real image, it's really clear, is that the rays are coming off of this point as if this is an object itself. So the moral of the story is the image of lens 1 is the object of lens 2. And you could do this for as many lenses as you want. If I had 10 of these in a row, the image formed by lens 8 is the object of lens 9. The image formed by lens 5 is the object of lens 6. But in our case, we just got 2, so the image formed by lens 1 is the object lensed by lens number 2. So basically, I just feed them through sequentially. And the thing that's less obvious, but is also true, is that if I have a virtual image, so if I made a virtual image that actually didn't go through and showed up here, for instance, I would still do the exact same thing. So even in the case of virtual images, all I do is I grab the image of lens 1 and pump it through lens 2. And to be clear, because I'm about to put focus 2 on there, these would be f1 for focus 1. So let me actually use green. So now I've got a thing that has f2 and f2. Right. And now I can do some ray tracing. So this one that comes in parallel, I've got to be diverging. So I go as if I came from f2. Love ray 3, so I'll just do ray 3 next, straight through the center. And then ray 2 is as if I were going towards this, the far side focus, and then I end up going parallel. And my sanity check is that these are all diverging, so I really do have a diverging lens. And then what I can do is I can trace them back, and it looks like I get overall the action of these two lenses in combination is that I create a virtual image that is inverted from the original object. So the first lensing made a real inverted image. The second lensing made a virtual image that's upright compared to this, but then inverted compared to the original one. So it's as simple as that. It's even if you don't actually have a real image, you have a virtual one, and it shows up here or here, you just take the object, take as the object for lens 2 the image from lens 1. So that's kind of nice. So there is a slight issue with this, and the ray diagram made it easy. I'll just put up a note, or a warning really. So, super important warning is be careful with distances. And symbolically, I'll write the thing that you shouldn't do. So D image 1, so the image formed by lens 1, in words, you might be tempted to write this, the object of lens 2, right? But this is not true. It's not actually that I just take the number thoughtlessly and dump it in there. And you can see that because I'll put some labels on this. What is the object distance for lens 1? Well, it's actually this. So remember, the object is always measured from, object distance is from object to lens itself. It's not, you can see on the diagram, it's literally not this number. It's true that it's the same thingy, but these distances aren't the same. So what I have to do in this case is DO2, that's a 2, mathematically is this distance in between the lens minus that. So be careful, don't just dump one number into the other. It's this thing, and then I have to readjust the length based on the fact that I'm now lensing with 2. So be a little bit careful with that. And then I would have DI2 would be this. Again, always measured from thing to lens. So that's your one warning. I'll leave this really big cluttered picture up, and we'll do a numerical example really quickly. And again, I'll go quickly and try to trip you guys up with the distance. So consider 2 lenses. And let's separate them by 1 meter because they're being uncreative. Okay, so I've got an object and it's 50 centimeters beyond lens 1 and even farther still from lens 2. And I've got lens 1 has a 30 centimeter focal length, lens 2 has a 20 centimeter focal length, and we'll just use h for the height. So essentially, it's this. So I've got a thing with a positive focal length, so that would be a converging lens. Could be meniscus, who knows, but it's definitely converging. And then 1 meter away, I have a diverging lens, and then 50 centimeters away, so we'll just not mix units because that's kind of gross, call it 0.5 meters away, I have this thing, and it's of height h. So it's really this, and we carefully draw out the ray diagram. Now we want to just put numbers on it, is kind of the point of this problem. Okay? So I'm going to be quick about it and just make sure that we don't make the mistake that you could make here. So first thing I want to do is I want to turn this into this. So I'll just draw 2 of the rays and find this. So this will be DI1, the image caused by lens 1. So I have 1 over f is 1 over d naught, as always, 1 over di. Make sure I get my signs right. So we'll call this the first lensing, or first lens. So that's 1 over 30 centimeters, and object is 1 over 50 centimeters, always positive, and 1 over di, 1. And then math happens, and di1 equals something or another, like 75 centimeters or something. Yeah, positive 75 centimeters. Okay, this is what I shouldn't do. course, this is the mistake, is I shouldn't take for the second lens 1 over f, technically that should be 1s across the board and 2s across the board, d naught plus di. This thing has a minus 20 centimeter focal length, object 75 cm plus 1 over di2, right? Why is that wrong? Well, because this isn't 75 centimeters. What I care about now is this distance. So this is d object 2, distance from the object, what used to be the image. The thing is the same, but again, remember you got to recalibrate the distances because for the first lensing, all these are measured with respect to this lens. For the second lensing, all these are measured with respect to this one. So not 75 centimeters, but rather 25, right? 100 centimeters minus 75 is 25. And yeah, that picture is not to scale, but don't judge me. Okay, and then second lensing happens, and this is about 11 centimeters with a minus sign, which means that we get a virtual image here. Okay. And just like our picture kind of depicted, yeah, minus means I didn't make it through the lens. So that is a virtual image located there. So I'm happy about that. Okay, and the last place to be a little bit careful is, if somebody asks you one of these questions, you got to be a little bit careful about answering the precise question that they asked. So for instance, if they ask how far from the first lens, well, that would be 1 meter minus 11 centimeters, so that would be 89 centimeters behind the first lens. If they asked you how far from the second lens, that would be 11 centimeters in front of it. So be a little bit careful about that. So we have an H, and the other question that could be asked is what's going on with the total magnification of this collection of 2 lenses? And there's a similar story. In this case, it turns out you can show that I would just multiply the individual magnifications from each lens, but we'll work it out because you probably won't be asked too many of these, so you don't have to come up with any cute shortcut formulas. So let's ask about the total lateral magnification. So we have M1 magnification by the first lens. We started with something that was height h. And both of these should have superscript 1. And we have di over d naught with a minus sign. I'm just going to leave off the superscript 1. This is the magnification after it passes through the first lens. Okay. So this is minus di over d naught. We actually have those numbers. The object distance is 50 centimeters, and then the image distance is 75. And minus is right because it's flipped. So we have minus 3/2, or 1.5. That's a very unphysicsy fraction. So I could say that the first image's height is minus 1.5 h, or I could say the magnification from the first lens is minus 1.5. Okay? And then I have the second lensing. So then it passes through the diverging lens. We call that M2. Likewise, that's hi over h naught minus di over d naught. And we have both of those numbers. So after adjusting, the object distance was 25 centimeters away, 25. And then the image distance was minus 11. So that's minus 11 centimeters and then 25 centimeters. And that's about half. That's like 0.46 or something like that, maybe. So 0.46. And then what I would do is realize that, wait a minute, I shouldn't multiply this by h because it's not shrinking something of height h by 0.46, a factor of 0.46, it's shrinking something that's this size by a factor of 0.46. So the height of the image after the second lensing is the height of the object times the magnification, both for the second lensings. And we know that that's minus 1.5 h, and then I'm going to multiply that by the 0.46, and roughly speaking, that's something like 0.74 or whatever, 73 h. But the better thing to do is rearrange this a little bit, and this is the kind of casual comment I made earlier, is h02 is equal to magnification times h01. So in fact, this is m1 times m2 times h. You can just see it by looking there. That's m1, that's m2, that's h. So if I had like 5 million lenses, I could just multiply all of the individual magnifications. But maybe you'll have to do 1 or 2 of these in your life, so I wouldn't worry too much about it. Okay. More interesting is applications of this. So there are 2 really common multi-lens thingies, aside from your eye and the corrective eyewear you may wear in front of it. And those are telescopes and microscopes.